Welcome to Summarize Science. Today, we're looking at one of the most violent events in the universe, a tidal disruption event, or TD. This is when an unlucky star wanders too close to a supermassive black hole and gets shredded into a long stream of gas, like cosmic spaghetti. For decades, astronomers have been trying to figure out what happens next. How does this stream of stellar guts settle down into a disk that feeds the black hole, creating the bright flare we can see from Earth? There have been two main ideas on how this happens. The first and original idea is that the stream loops around the black hole and then crashes into itself, like a serpent eating its own tail. But a more recent idea, supported by many computer simulations, suggests something else happens first. This theory proposes that as the stream whips around the black hole at its closest point, it gets squeezed so hard that it creates a powerful shockwave, kind of like a cosmic fire hose nozzle. This nozzle shock would violently heat and spread the gas, playing a major role in forming the disk. But a team of researchers decided to test this nozzle shock idea with more power than ever before. Using a new code called SPH-EXA on one of the world's most powerful supercomputers, they created the most detailed simulation of a TD to date. We're talking about tracking 10 billion individual particles, which is over 100 times more detailed than many previous high-end simulations. And what they found was stunning. Look at these images, which show the stream of gas at different simulation qualities or resolutions. On the left, with fewer particles like in older simulations, you can see the stream gets messy and sprays out after passing the black hole, just like the nozzle shock theory predicts. But as the researchers crank up the resolution, moving from left to right all the way to 10 billion particles on the far right, that messy spray almost completely vanishes. The stream instead stays incredibly thin and neat as it whips around. This plot confirms it. The amount of energy lost in this nozzle area drops dramatically as the simulation gets more detailed, becoming almost irrelevant at the highest resolution. The researchers concluded that the violent nozzle shock isn't a real physical process, but a digital illusion caused by not having enough detail in previous simulations. It's like looking at a pixelated image and thinking the blocky artifacts are part of the real picture. This means the post-paracenter spreading of the gas is not driven by shock heating. So let's recap the important points. The idea that a stream of star guts gets violently shocked and sprayed out near a black hole is likely wrong. It was probably an illusion created by less powerful computer models. Instead, the original theory that the stream stays relatively cool and thin until it collides with itself is probably the correct one. This is a big deal because it changes how we interpret the light from these events. It means the flares we see from TDs are more directly tied to the specifics of the star and the black hole, not just a generic explosion. With new telescopes like the Vera Rubin Observatory set to discover thousands of these events, this new understanding will be crucial for using them to probe the secrets of supermassive black holes. This research brings us one step closer to understanding the chaotic dance between stars and the monsters lurking in the hearts of galaxies.